Hi guys, hello everyone. It became so much late. Based on request of some of our subscribers, I am going to start physical chemistry. Previously, I have done videos based on atomic. Previously I have done videos on organic chemistry. I have done 70 videos. I have posted. Now I'm going to start now. The concept of physical chemistry. It is atomic structure. Right. Let us see here. All right. In atomic structure, the first one you can see here, you know, what do you mean by atom? Atom means, that according to Dalton's atomic model, it is indivisible. Okay, it is a Greek word. Okay, atomio. In the Greek, it is atomio, which is called indivisible. That means the smallest particle of the matter was atom. It is according to Dalton, you can say that. According to Dalton's atomic model. But, you know, afterwards, what happens here? Um Discovery of fundamental particles takes place. What are those fundamental particles? You know that fundamental particles are electron, you know that very well, and second one is proton, and the third one you can see here neutron. Yes, these three particles we can say here electron, proton, neutron. By the discovery of these three fundamental particles, Dalton's law loses its identity. It's lost its identity. Why? Because according to Dalton, what it is, atom is the smallest particle of the matter, according to Dalton. But after discovery of these three fundamental particles, you know, it, it's it lost its identity. We can say that. Okay, yes, that's the point you have to keep in mind. అంటే ఇక్కడ ఏంటి ఎలక్ట్రాన్ ప్రోటాన్ న్యూట్రాన్ ఈ త్రీ పార్టికల్స్ ను డిస్కవర్ చేసిన తర్వాత డాల్టన్స్ లా అనేది ఇట్ వాస్ లాస్ట్ its identity, you can say that. Dalton's atomic model. Okay, yes, let us see one by one. Right here, when you observe the electron was discovered by whom? We will go through one by one. Let us see here. Electron. Electron was discovered by whom? J. Thomson. J. Thomson. The scientist name you can see here. J. Thomson. You can say that. Okay. Right. Now, yeah. Actually, here he called electron as cathode rays. What he called, by using which experiment he did? Cathode ray discharge tube experiment. Which experiment is that? Cathode ray discharge tube experiment. Okay, by using cathode ray discharge tube experiment. What is actually cathode ray discharge tube? Let us see here. It is a closed tube. You can see here. It is a closed tube. It is connected to a battery. Connected to a battery in this manner. These two metal plates. What are these? These two metal plates we can say here. It is a negative metal plate. This is negative metal plate, and it is positive metal plate. We can say that. Negative metal plate is called as cathode, and positive metal plate is called as anode. You can see here. Okay. Yes. It is connected to vacuum pump. Why is it? Because gas is present in this cathode ray tube. What is present? Gas. That's why Here, the cathode rays tube experiment or cathode rays, we call them as cathode rays. Cathode rays, you can say here. Cathode rays are negatively charged particles. These are depends on the nature of the gas present in the cathode ray discharge tube. Here it is which one? Vacuum pump. Which pump it is? Vacuum pump, we can say here. It is connected to vacuum pump. Why is it required vacuum pump? Cathode rays were produced only when the two must and should conditions are required. The first condition, here it is, you can see that. First condition, let us see, very high voltage is applied. Here, voltage, this is the voltage is applied by using battery. Very high voltage, it is required. Okay, yes, that is around 10,000 volts. It is very high voltage, you can say here. 10,000 volts is required. And the second condition is what here? By using vacuum pump, I am writing the second condition here. By using vacuum pump, you have to create very low pressure. Very low pressure. That is what? 0.01 millimeters of Hg, mercury. It is in barometer reading, you can say here. 0.01 millimeters of Hg, it is required. When you apply these two conditions, only the cathode rays were produced. Okay, in the cathode ray tube experiment. Then, how the cathode rays were travel? They produced at the cathode and move towards anode. Cathode rays where they are produced, when you apply these two conditions, okay, here they move towards anode. You can say that. Okay, right. Here, these rays are, travel in straight lines. Okay, they are traveling straight line in absence of electric and magnetic field. Okay, here properties of cathode rays are characteristics when you observe here. I am writing first one. They travel in straight lines, you can say here, straight lines. And the second one, in absence of electric and magnetic field. In absence of electric field as well as magnetic field. In magnetic field, we can say that. Okay, means there is no deflection. There is no deflection in absence of electric and magnetic field. They travel in straight lines. Okay, yeah. Second one is what? Deflection takes place in presence of electric and magnetic field. Deflection takes place in electric field and magnetic field. You can say that. In electric field and magnetic field, deflection takes place. We can say that. And one more important point you can see here. Right. In presence of electric field, they are deflected towards anode. It is important. In presence of electric field, deflected towards what it is, they are deflected towards anode. Why they are deflected deflected towards positive terminal of the electric field. Positive terminal of electric field, you can say that. Why they are deflected towards positive terminal of electric field? Why? Because they are negatively charged. Since they are negatively charged, they are deflected towards electric field. And the next one, in presence of magnetic field. Okay, in presence of magnetic field, you can see here, in presence of magnetic field, they are deflected towards south pole of the magnetic field. Which pole? South pole of the magnetic field, we can say here. Okay, we can say that. South pole of the magnetic field. These are important points, we have to keep that. Okay, right. Yes. Next one you can see here. Cathode rays, you can say that it is found to be independent of the nature of, these rays are independent nature of material that is used for metal plates. Whatever we are taking the metal plates, no, anode and cathode metals we are taking, right? Yeah, electrodes we call them as cathode electrode, anode electrode, or metal plates. We say that the material, it is independent. Cathode rays are independent of material for cathode and anode, whatever you have taken. Okay, that is important point you have to keep in mind. But these rays are depends on what? Nature of the gas present in the cathode rays. Okay, here third point is what here? Depends on, these rays depends on the nature of the gas. Independent of the nature of the gas, I'm sorry, not depends. Independent of the nature of the gas, because the charge of electron is always remains same. Okay, it is independent of the nature of the gas, we can say here. Independent of the nature of the gas, because charge of electron is remains same always. Charge of electron is remains same. Okay, keep that in mind, all of charge, because charge is same always. Charge of electron is same always, you can see here. Okay, right. Those are the properties of the cathode rays or characteristics of the cathode rays, we can say here. Okay, yes. Yes, next one, let us see here. J.J. Thomson, one more thing he did was, he was able to determine the specific charge of electron. Specific charge means what? This is also called as E by M ratio. Which ratio? E by M ratio, or we call it as specific charge of cathode rays, or for electron we can say that. The name electron was given by scientist name, Stoney. Stoney. J.J. Thomson, what he called them? Cathode rays. But Stoney called electron. Those negatively charged particles are called electrons, was given by or proposed by Stoney. Keep that in mind, all of you. Yeah, E by M ratio. How E by M ratio by J.J. Thomson? Let us see here. When you take here, yes, let us see this. Here it is cathode, and here it is anode. They travel in, the similar setup. You can see here. It is also a cathode ray discharge tube, and it is negative terminal and it is positive terminal, means battery. Yes, you can see this. Right. Now, these rays were travel in straight line directions here, in absence of electric and magnetic field. But when you apply the electric field, this is cathode. Yes, it is cathode, and this is anode. We can say that they travel from cathode to anode. We can say here, this is the positive terminal of the electric field. You can say that, and it is negative terminal. In perpendicular direction, the electric field applied. See, this is the propagation of cathode rays, and it is perpendicular direction electric field applied. You can say that. Then these rays are deflected towards the positive terminal of the electric field. These rays are deflected towards the positive terminal. It is point A. If there is no, here in presence of which field, it is electric field. In presence of electric field, we can say here, right, right, you can say that. And the next one, if there is no electric field or magnetic field, they travel in which directions? I told you, travel in straight line direction, that is point B. In absence of electric and magnetic field, no electric field, no magnetic field. Okay, no electric and magnetic field, then they travel in straight line directions. In presence of electric field, they are deflected towards positive terminal. Next, in presence of magnetic field, how it looks like, you can see here, when you observe, this is the electric field, and it is the propagation of cathode rays, and magnetic field is applied perpendicular to this. Means you can see here, you can observe my fingers. This is the propagation, and this electric field or magnetic field are perpendicular to each other. Therefore, here when you apply magnetic field, then these rays are deflected towards south pole. Means you can see this magnet. If you consider, I am writing here in perpendicular manner. If you observe that, it is the north pole. Yes, here it is south pole. It will be like this. Okay, perpendicular to that. Then these rays are deflected towards south pole of the magnetic field. This is south and it is north. Yeah, it will be like this. It is they are deflected towards south pole of the magnetic field. We can say that. By using this, he was able to determine, actually, you know, if the mass of the particle is light, deflection is more. Okay, deflection is inversely proportional to mass of the particle. Mass of the particle is inversely proportional to extent of deflection. Okay, inversely proportional to deflection. If the deflection is more, mass is less. Okay, you can say that. Okay, yeah, that's why deflection and mass of the particle. By using this, what he did was, he was able to find out the E by M ratio, or we can call it as specific charge. Okay, yeah, he was able to determine the specific charge. Let us see that. Specific charge, how much? He was able to determine experimentally by using this. See this experimental setup, you can see that in olden days, picture tubes, olden days TVs, it will be like this. This is the screen, and backside dome will be there. You can observe that this is called cathode ray tube. We call it as LCD TVs. We say that LCD cathode ray tubes. That's why you see here that setup. Yeah, E by M. He was able to determine E by M of electron. You can say that is equal to 1.7588 into 10 power 11 coulomb per kg, kilogram, or this value can be written as 1.7588 into 10 power 8 coulomb per gram. That is the value, you can observe that. Okay, that is the case. You can see here, right? 1.7588 into 10 power 8. Okay, yes. Actually, one more scientist came with an idea. The scientist name is called here Millikan. Millikan, by using Millikan oil drop experiment, he was did that. And one more point here we have to keep in mind: mass of electron. When electron moving, there are two types of masses it can have. How many types of masses it have? Two types of masses. What are those? First one is rest mass m naught. You can write here m naught. M naught means rest mass. You can say here of electron, rest mass of electron. Next mv, mass of moving electron. When it is moving with some velocity v, mass of moving electron. Let us see that, because it is very tiny particle, no? Mass of moving electron. There are two types of masses an electron have. Okay, any electron, if you consider the electron present in any atom, whatever the atom it may be, it has two types of masses. One is rest mass, another one is moving mass. Mass of moving electron, you can consider it as, mv is equal to m naught by 1 minus v by c whole square root over 1 minus v by c whole square root over. We can say that. Okay, yes. Here it indicates what? It is mass of moving. It depends on the velocity of the light. Keep that in mind, all of you. Velocity of light, because when velocity, because it's very very tiny particle, you cannot even see that, right? Very micro particle, right? It's a micro particle. Electron is a micro particle. That's why it moves with some velocity. You see, the condition is, the important condition when you see here, if velocity of electron is equal to velocity of light. C means what here? C is called velocity of light, V is called velocity of electron. Keep that in mind, all of you. Yeah, when if velocity of electron is equal to velocity of light, how much 3 into 10 power 8 meter per second. You can say that. Okay, keep that in mind, all of you. Yeah, if V equal to C, then 1 minus 1 becomes 0, m by 0 becomes infinity. Okay, keep that in mind. Therefore, here if V equal to C, mv becomes what? Mv becomes here infinite. That means mass of moving electron becomes infinite. Keep that in mind, all of you. Okay, yes. This is about, E by M ratio of electron. Keep that in mind. Okay, yes. Here it is in olden days picture tubes, it will be like this. This is the screen and it is dome, back side of that. And nowadays we are not using, only LED TVs we are using now. Okay, yes. This is the information about, okay, electron. Okay, yes. Now J.J. Thomson was able to determine the E by M value. But charge of electron did by whom? The scientist name was called Millikan. What is his name? Millikan. Millikan did here the experiment, Millikan oil drop experiment, we can say here. Millikan oil drop experiment, you can say that. Yes, by using this Millikan oil drop experiment, he was able to determine, uh, you know, he was able to determine the charge of electron. It's very important and simple concept. Here, Q is equal to N into E. He was given this equation. What is Q here? Let us go through. Q is charge on oil drop. Okay, here n, n is what here? Number of electrons. Okay, how many electrons are there? You have to find out on the oil drop. Okay, therefore into charge of each electron, it is overall charge. We can consider it as which charge? Overall charge. Overall charge means, all the electrons charge. We can consider charge of each electron. Yes, you can say that. Now, here, charge of each electron, how much? He was able to determine the value of charge of electron is charge is equal to E is equal to charge of electron is equal to 1 point minus negative sign, it comes here, minus 1.6022 into 10 power minus 19 coulombs. What it is? Coulombs. See, this is the charge of each oil drop. E is equal to, he was able to determine the value of charge of an oil drop is minus 1.6022 into 10 power minus 19 coulombs. That is the oil drop experiment done by Millikan. Yes, by using this, what we can do? Mass of electron we can determine. By using this, what we can determine? Mass of an electron we can determine. Mass of electron how much? Let us see that. Therefore, mass of electron is equal to mass of electron. That is, which mass it is? Most probably rest mass of electron. Keep that in mind, all of you. Rest mass of electron is equal to you can see that, because when oil drop is, when electron is present on the oil drop, it does not move, no, that's why it is called as rest mass of electron. M naught is equal to E by you can write it as E by M naught. E is how much? 1.6022 into 1.6022 into 10 power minus 19 coulombs by, you can see that. Is that clear, all of you? Okay, just observe here clearly. 1.6022 into 10 power minus 19 coulombs by E by M, how much value here? E by M 1.7588 into 10 power 11 coulomb per kg. Coulomb cancelled out, only kilograms. Denominator of denominator becomes what? Numerator. Therefore, E by M, you will get it here, charge by charge, specific charge. You can write it as M naught equal to what you can write here? M naught is equal to charge by specific charge, that is equal to 9.11 into 10 power minus 31 kilograms. This is the mass of an electron. Keep that in mind. What is that? 9.11 into 10 power minus 31 kilograms. The mass of one electron, that is rest mass, most probably we say that 9.11 into 10 power minus 31 kg. It is always fixed value. Here it is fixed value. E by M also fixed value. You keep that in mind. And M naught also, this is fixed value. Okay, yes. Here, this is the information about, you know, electron. Okay, keep that in mind, all of you. Right. Yeah, when you look at here, discovery of anode rays. Here these are cathode rays, we have seen that. Now anode rays, the similar setup you can see here. Discovery of anode rays, when you observe here, yeah, anode rays are also called as canal rays. Keep that in mind, all of you. Anode rays are also called as canal rays. Yes, when you observe this, canal rays here, discovered by the scientist name called Goldstein. Goldstein, you can see that. Yes, you can see. Here is the scientist Goldstein, and according to him, same experimental setup. What is that? Same experimental setup you can see here. Okay, right. When you observe two metal plates are there, cathode, anode. You can see that. Okay, here actually, see, the point we have to keep in mind, these rays are travel from where to where, from it is cathode and it is anode, we can say here, and they travel from anode to cathode, towards anode to cathode in straight line directions. You keep that in mind. In this manner, they travel towards from anode to cathode. See, the important note, what you have to keep that in mind, these rays are invisible. What is not? Either cathode rays or anode rays. Cathode rays and anode rays are invisible. Invisible. How can you observe that then? How can you observe that those are invisible? We can say that, you know, when you take the when you can observe them, by using the material called fluorescent or phosphorescent material, you can say that. By using fluorescent or phosphorescent material, because those are invisible. But here you can observe them. If you take the material is called here zinc sulfide. Which one it is? Zinc sulfide material. It's a fluorescent or phosphorescent material when you consider like zinc sulfide. Any material you can consider fluorescent, either fluorescent or phosphorescent. Similar kind of that is zinc sulfide. When you take coat on the back side of the cathode, it is perforated cathode. Perforated means called, it contains some holes. Perforated cathode means contains some holes. Then when these rays travel through the cathode, and when they fall on the material coating that, then it glows because it is fluorescent. No, when these rays are falls on that, it glows. Therefore these are invisible and they can be observed by using the fluorescent and phosphorescent material. Keep that in mind, all of you. Okay, yes, right. Now come to the point. When you observe here, these are cathode rays and anode rays. When you observe, cathode rays are negatively charged particles and anode rays are positively charged particles. We can summarize it. And cathode rays generated at the cathode and move towards the anode in straight line directions, whereas anode rays starts from uh, you know anode and move towards cathode. You can say that. And here also, these are also influenced by the electric and magnetic field. You know, in absence of electric and magnetic field, they are traveling straight line directions. In presence of electric and magnetic field, similar manner, we have seen that these are negative terminal. They are deflected towards negative terminal of the electric field because these are positively charged. Okay, therefore, and north pole of the magnetic field, you can say that. That is the characteristics of these rays. We can observe it. Okay, yeah. When you observe the characteristics of these rays, and one more important point about these rays is they depend on the nature of the gas. Anode rays depends on nature of the gas. Why is it so? Why? Because let us see here. One of the example or one or two examples. Let us see here. How they depend on nature of the gas. Let us see. Right. Yeah. For example, you see here when you consider E by M ratio, uh, hydrogen is there. It gives H plus plus electron. Okay, when it ionizes, it gives H plus hydrogen. Yeah. Here gas you have taken gaseous atom, then it gives hydrogen gas, H plus electron. What is the charge here? Charge of proton, it is EP, we call it as. Charge of electron, simply you can write E. Charge of proton is equal to plus 1.6022 into 10 power minus 19 coulombs. Plus, it is the only sign will be changed, remain same. Here it is minus sign, for electron minus sign, that is negative, it indicates negatively charged. Magnitude is remain same, keep that in mind. Only sign will be changed. Magnitude is remain same, we are considering magnitude here. Mass means magnitude, related to magnitude, sign will not be considered. Why? Because here it is a negatively, it indicates negatively charged particle. Here it is indicates positively charged particle. Keep that in mind, all of you. Okay? Yeah. Here, therefore, for example, if you take helium, gaseous helium, then what it gives? He plus 2 gas plus 2 electrons. Here, charge of each electron is how much? They can exist independently. Charges remain same for each electron here. It will not change. But charge of He plus 2 what? Charge of He plus 2 is Ep is equal to 2 into plus 1.6022 into 10 power minus 19 coulombs. Why we have to take 2? Why? Because it contains how many? 2 protons. Anode rays. Anode rays nothing but proton, number of protons. Number of protons how many in helium? 2. Therefore, 2. That's why anode rays depends on the nature of the gas. If it is only plus 1, 1 into 1.6022. If it is 2 times, 2 into 1.6022. You can say that. Okay? Yeah. Here, that's why E by M value of anode rays are less than E by M ratio of protons or anode rays is less than E by M value of electron. Keep that in mind, it is important. What is the reason behind that? Why? Because it depends on the nature of the gas. You can see here. Then E by M ratio of value of proton how much for H gas? How much it can be? Mass of proton we should know that. To find out E by M ratio of proton, yes, mass of proton how much? Let us see. Mass of proton is equal to 1.673 into mass of proton is equal to 1.673 into 10 power minus 27 kilograms. 1.6732 into 10 power minus 1.673 into 10 power minus 27 kilograms. If you convert that into grams, what you can write here? Yeah, let us see that. 1.673 into 10 power minus 24 grams. 1.673 into 10 power minus 24 grams. You can keep that in mind always. Now, here E by electron and proton, charge of proton by mass of proton means 1.60 plus 1.6022 into 10, because sign will not be considered in case of magnitude. 10 power minus 27 kilograms by 1.673 into 10 power minus 24 grams. Sorry, 27 you consider. Minus 27. Oh, here charge 10 power minus 19. I'm sorry. Yeah, here coulombs. Consider it as coulombs. 1.6022 into 10 power minus 19 coulombs by 1.673 into 10 power minus 27 kg. Consider it. Right. Now, here it can be considered as 1.6022 to 1.673. How much it can be? 0.958. 0.958 into 10 power, how much it becomes? Plus 27 minus 19. It is minus 8 kg. Coulomb per kg. You will get it. Here, if you displace this, yeah, you can write it as minus 27 means if it goes up plus 27 minus, oh, plus 8, I'm sorry, plus 8 you consider it. Right. Now, yeah, 27 minus 19 means plus 8. Now, here it can be 9.58 into 10 power 7 coulomb per kg. Coulomb per kg. This is the E by M ratio of proton. You can consider. E by M ratio of proton is how much? 9.58 into 10 power 7 coulomb per kg. Yes, keep that in mind. See, now compare E by M ratio of electron and E by M ratio of proton. E by M ratio of proton is lesser than E by M ratio of electron. Therefore, for proton only we are considered here. Proton means this one. Proton means this is the proton we can consider here. Yes. Yeah, here it is He plus 2 is called what? Alpha particle. Keep that in mind. Alpha particle. Keep that in mind. Yeah, for alpha particle is it same E by M ratio? No, it will not be same. Why? Charge will be different. 2 times you have to consider. 2 into 9.58 into 10 power 7. Therefore, here that is E by M ratio of proton when you consider that E by M ratio, because here you have to keep that in mind. E by M ratio is smaller, that is 10 power 11. For the electron 10 power 11, it is 10 power 7 only. That's why E by M ratio of electron is greater than E by M ratio of proton. Keep that in mind, all of you. And one more point here. One more point you have to keep in mind. Alpha particle can also be produced by using the nucleus of nitrogen. Nitrogen nucleus, you know that very well. 7n14. Okay, atomic number, or you can say number of protons are 7. Mass number is 14 plus helium alpha particle 2He4 24. Number is 2, mass is 4. It gives rise to proton. Proton it gives. What it gives? Proton it gives 1H1. You can write it as, proton can also be written as 1H1 plus, okay, O817. 14 plus 4 how much? 18. 7 plus 2 how much? 9. 1 plus 17 how much? 18. here 1 plus 8 how much? 9. Therefore, the 18 9, 18 9. It can be, it was produced by whom? By bombarding alpha particle. Here it was done by Rutherford. Who did this experiment? Rutherford. Rutherford did that. He was able to, by using the nucleus of nitrogen and new alpha particle. Alpha particle means 2He4. He was done that by using that. This is called artificial radioactivity. By using he was able to, Rutherford was able to produce alpha proton by using or cathode rays. Sorry, by using anode rays. He was able to produce anode rays by using artificial radioactivity. Keep that in mind, all of you. Okay, let us stop here today. Thank you, one and all. Okay, if you have any doubt, you can write in comment section. Thank you very much.